Hello everyone. So today I will discuss the first three problem of the Stata 196, and this is the take three. So move on the first problem. So first is the problem. The problem says Alice along with n of her friends visit her bakery. There Alice initially bought cake quiz and Ayat friends bought AI quiz. So it says the Ellis and his and friends go in the bakery and choose some and bought some cookies and bought some cookies. So Ellis bought C cookies and the ayat of his friends buy the AI cookies. And again it says that the Ellis is quite competitive, so only happy he will only be happy if at least one of friends has strictly less cookies than her, and no other friend has equal cookies to her. What is the minimum number of extra cookies Alice must buy to ensure that she is happy? So basically, it says that the Alice will happy when the Alice will happy when the cookies as the Alice is greater than the at least one element of its at least one cookies that has its friend means Alice will happy if let's say Alice has the total cookies is three, then Alice will only be happy if there is at least one friend that has the lesser cookies than the Alice cookies, and the total cookies that has the Alice has is not equal to the any cookies of its friend. So you need to find out the minimum number of operations to make the Alice happy. So first is the is input and output format. So in the input, the first line gives the t, which is the number of test case, and for each test case, you are given two lines. In the first line, you are given the n and the c, which is the number of friends and number of cookies that Alice bought initially. And the second line contains n separate integers a1 to an, which is the counts of the cookies bought by Alice friends. And for each test case, we need to print the output on the new line. The answer, the minimum number of extra cookies Alice must buy. So pick the first test case. So basically, Alice has three friends, and the initial cookies that the Alice has five, and the and age friends has the cookies 10, 5, 3 respectively. So I will check the initially the Alice has the five cookies. Then is there any Alice friend whose the cookies is lesser than five? Yes. Then present is the three. It is the lesser than the three. And also I will check the is there anywhere the five is not is there anywhere five present not in the number of cookies in the Alice friends. So here is the five present. So I cannot take to this five. So I we need to increase this amount. So let's say Alice take the one more cookies. So the total Alice has the six cookies. So it will check that is there anywhere the his friend has the cookies which is the lesser than the six. Yes, there is the two cookies, which is the three and five, which is the lesser than this. So that is fine. And again it will check the is there any friend has total six cookies? No. So it will be the our means total final amount of the cookies that is that is present as LD size. After it, then how many the total amount of the cookies extra needed needed to the Alice. So the I will take the one extra cookies. After it, it will make the Alice good. So the our answer is the one. So how I will analyze to it? Let's say here. So first I will pick the this form, this statement. So how I will apply the any approach on this? Initially the Alice has 5 rupees. So rather than the checking the all elements which is the lesser than or equal to the 5, I will I will sort the array. Then on sorting, the array becomes an increasing order, and after it I will check the total amount of the list with only the first element by the only with the first element. Then if anywhere the amount of the list is greater than the first element, means zeroth element, then that is fine. And I will check the if any and I will check that if anywhere the the number of bakeries that the Alice has is not equal to the any other elements, any other person versus bakeries. Then what I will do, I will take the total amount of the list that is present and minus initially amount of the bakeries that the Alice bought. It will be the answer. So this is the much easier problem. You can solve this problem in the Vigo of n square. Even it will also be accepted in the Vigo of n square, so n cube. So go on the code. So first I will take the t, which is the number of test case, and for each test case I will take the two integer. First, this is the number of Alice friend, and and second is the amount of the bakery that the Alice has. And after it, I will take the array and I will take the input array and I will put all the amount of the bakery and means all the bakery that has the Alice friends. I will put all these into the map and after it I will sort the array and I will check minimum how many I can find. So initially it may be the Alice has the amount C, which is the already fulfill the condition. So we not need to take any extra bakery. So in this case, so minimum our answer can be the 0 and how in the maximum our answer. So let's say and you can see here the constant. So the maximum value of the AI will be the 101. So maximum value of the AI is the 100. So and let's say there is only one friend of the LS and the LS not by any amount. Let's say this is the 0. So in this case, LS need to buy the 101 one bakery so that it apply the condition and it will fulfill the condition. So the minimum value of the answer will be the 0 and maximum value will be the 101. So it is pretty simple. I will go from the 0 to 101 and I will check if anywhere, let's say I will take the 0 amount, then the total amount of the bakery that Alice has will be the C plus I. If it is greater than the first element means smaller element and also the total amount that the Alice has, which is the C plus I, is not present in the array, means is not present in the map, then I will put to that number into the answer and I will wait. After it, I will print to this. So that is all for first problem. Move on the second problem, which is the sugar limit. So first is the problem, what it said. So it says they have got n different snacks and now he need to decide which one to eat. The IH snack has the tastiness of AI and contains BI unit of sugars. Note that the AI can be the 0 or even negative. Then It says then Alice bought n different snacks, and the ith snack has the AI testiness, has the AI testiness, and it has the BI amount of sugar in the and it has the BI amount of sugar in the ith snack, and the testiness of the ith snack. It is possible that the testiness of the ith sugar is negative or zero, and even it is the positive. So it may be anything. And Jeff want to limit his sugar intake, so he will choose some negative integer L, and then he can only eat a snack if it has at most L unit of sugar. That to say that satisfies the BI lesser than or equal to L. Note that he cannot need to eat every snack that satisfies the BI lesser than or equal to L. He can he can decide to skip some of them too. So basically, Jeff choose any integer L, and after the choosing any integer L, Jeff will is able to eat the any any snack which the which the sugar amount is lesser than or equal to the L, but there is no need to eat but there is no necessity to eat the all the amount all the snacks that fulfill the condition. So it depends on the Alice that if he will eat the zero snacks or one snacks, the all the snacks that follow this condition. But it is sure that the Alice will only eat to that snack which that follows this condition. So what it says, let S denote the sum of the testness value of all snacks they've decided to eat after choosing the value of L. Okay, so basically S denote the sum of testness value of all snacks the chef decided to eat. Okay, chef satisfaction then equal S minus L. That is chef satisfaction is the sum of the testness value of everything he ate minus threshold value. What is the chef's maximum possible satisfaction if we choose the value of L and snacks he ate appropriately? So it says then after choosing this, let's say the amount of the total testiness of the Alice of the product that the Alice ate is the S. Then you need to maximize the value of the S minus L. So basically, it says that you have the n snacks means Alice has n snacks and ith snack has the testiness value AI, and the amount of the sugar in the ith snack is the BI, and you should choose any integer L, and after it you are able to eat the any snacks that fulfill this condition means that has the sugar is lesser than or equal to the L, and after it you will choose some snacks that fulfill this condition and you eat to that snacks, and the total, let's say the total destiny of that eaten snacks is the S. Yes, then you need to find the value of the S minus A, yes, which is the maximum. So let's say move on the input. So basically, first line of input is the test case, and in each test case, you are given the first line is the number of snacks, and the second line is the testness value of each snack, and third line is the sugar quantity of each test case means sugar quantity of each snack, and the output you need to print the for each test case you need to print the output the maximum possible satisfaction check when achieved. Here you can see the constraint. So the constraint is pretty simple. You can move the solution on the you can write the solution in the Vigo of and we go of n squared. Even the we go of n cube will also be accepted. So first, see the first test case. So you are given these two snakes, and the distance of the two snakes is the 4 and -1, and the amount of the sugar of these two testness is 2 and 4 respectively. So basically, for the zeroth, for the zeroth snack, the amount of the tastiness. This is the tastiness of its product, and this is the sugar quantity of the ith product, means ith snack, and this is the first snack. So let's say if we choose to the any integer, let's say if we choose to the L is the 1, means the you need to find out the total snacks that has the sugar value, which is this is the b, that has the sugar value is lesser than or equals to L. So there is no snacks that follow this condition. So let's say if I will choose the L equals to 2. So on choosing the L equals to 2, I will I will see that this this snacks will fulfill this condition. So for this, there is one snack that I got, and the tastiness of this snack is the 4. So the our sum of the tastiness that we eat is the 4. And then the our answer is the S minus L is the 2. But I will not stop here. 2 maybe the our answer are the answer exists which is the greater than 2. So I will also check to the other. So let's say if I will take the 3, means the I am interested to find out the is there any snacks that has the sugar amount which is the lesser than or equal to the L. Yes, then I got this again. So for this, it will be the sugar amount of the eaten total amount of the tastiness of the eaten bakery, which is the 4, and the minus you choosing the value of the L, so it will be the 1. But in the previous I got the maximum, so I will not consider to this. So from now the answer is the 2. After it I will choose the, let's say L equals to 4. So I see here, uh, I found two snakes that follow this condition, which is the b is lesser than or equals to the L, bi is lesser than or equals to L. Yes, so I will eat to both the two snakes. Then the amount of sum of the all the tastiness of both the snakes will be the 4 minus 1, which will be the 3. And so our answer will be the 3 minus 4, which is the 1. But in the previous I will got the 2. And you think from the year, that the value of the snakes means our answer will never be lesser than the 0. Why I will not be lesser than the 0? Let's say here. So let's say if I will not choose the any sugar, means I will choose the L equals to 0. Then after it, I will not got the any sugar. I will not got the any snacks to it. So the sum of the tastiness of the eaten next will be the 0. So our answer will be the 0 minus 0, which is the 0. So I am sure that our answer will be the always greater than or equals to 0. You can see the here. So I got the answer will be the 2 maximum for this test case. You can verify from the here. Yes, you got it. So how I will think about this? Then here what I will do? I will check the one by one, that is there anywhere the I can choose the value of L, which is the 1, 0, 1, 2, 3, even 1 to, from where I will choose to the maximum element. till the maximum element. Why I will choose to till the maximum element? Because after it, let's say here I will choose to the L equals to 5. Let's see. So if I will choose here, I will choose L equals to 5. Then the sum of our testiness means total testiness that total snack that I will it will be this testiness and this testiness. So after it, I will the total number of sum of the 18 testiness will be the 4 minus 1 will be the 3, and the value of our answer will be the 3 minus 5. So it will be the always lesser than the when I will choose to the maximum snaps. So I will not choose the value of the L beyond the greater than the maximum element. So I will choose the value of the L from 1 to M, from 1 to maximum of the value of snacks, and I will check the if in and for each L I will check the condition, and if anywhere the amount of the amount of the sugar of the ith snack is lesser than or equals to L, then that is fine. I will take to that destiny in our means I will eat to that destiny means I will eat to the that snack. Sorry, I will eat to that snacks. But when the testiness of that snacks is greater than the zero, then only I will eat because the if I will I will eat to that snacks with testing value is lesser than the zero, then on adding to this, it will decrease to the our the answer. So if anywhere this condition hold, then I will add to the test means I will add the amount of the testness in our the sum, and after it, I will on processing on the complete snacks, I will subtract the value of L from the yes, and I will take the maximum. So move on the code. So first, basically, I will take the T, which is a test case, and for each test case, I will call for the solve function, and in the solve function, I will take the value n, which is the total number of snacks, and for each snacks, I will take the a, which is the amount of the test snack for the ith snacks, and amount of the sugar that has the that has the uh, ith snacks, and I will initialize to the answer by the zero means the our the initial answer is the zero, and I will move from the one to the 101. Why I will move till 101? Because the maximum amount is the 100, and basically it will move from the 1 to 100, and which is declared on the above code. You can see from the here that f of I from A to B, it will not move from the A to complete of the B. Means on the B, it is the in, exclude. So for the 1 to 100, I will take the all the testiness that follow this condition, and I will add to that into the our answer, and after it I will take the s minus the choosing the value of the L means the value of the I, and I will take the maximum of the previous and the current answer, and after it I will print the answer. So basically that is all for second problem. So see the third problem. Move on the third problem. So basically what the third problem says, the third problem says the append average. You are given an array of length n. You are given an array A of length n. You must perform the following operation exactly k times. Choose two distinct indexes I and j. Then, if ai plus aj is even, then append the ai plus aj by 2 in A. If ai plus aj is odd, then append the ai plus aj plus 1 by 2 to A. N is increased by the 1. Find the minimum possible sum of the final array after performing this operation k times. So the problem is straightforward. What is it? See here. Uh, you are given an so basically you are given an array. You are given an array of n size, and you have also given the size of the array is n, and you are also given an array k, which is the integer. Means you need to perform the exactly key operation on this array, and in each operation you choose to that two indexes, and let's say you can choose two indexes I and j respectively, and you show that the I and j is not equal, and after it you find the value of the ai plus the value of the ai plus aj, and if the value of the ai plus aj is odd, then you need to append the ai plus aj by 2, and so if it is the even, so you need to print the ai plus aj by 2, but if when it is the odd, then you need to append in the array which is the ai plus aj plus 1 by 2. So after each operation, the value of n is encaged by the one, means size of array is encaged by the one. After it, let's say in the first operation you perform this operation, and after it you perform the another operation, means you choose to other indexes I and j, or you choose to the same index I and j and append into this. So after the kth operation, the you need to, let's say after the kth operation, the array will become the a1 a2 till an plus k. Because why n plus k? Because on each operation the value is in each operation the size of the array is increased by the one. Then after the k operation the size of array is increased by the k. So you need to find the sum of this and ensure that the this sum should be the minimum. So why how you can apply to this, so that the sum is the minimum. So you need to find out this sum, yes, which is the minimum value of the sum of the minimum value of the final array. So move on the test input and output format. So in the first line, which is the t, which is the number of test case, in the five test case you are basically given the two lines of input. In the first line you are given the n and k, which is the length of array and the number of times the operation must you need to perform. And in the second line you are given the n separate integers a1 to an, which is the value of the array, and you need to find the output of five test case, which is the minimum possible sum of the array after key operations. Okay, so first take the first input and analyze this problem. So basically, in the first test case, we have given the five size of the array, and you need to perform the operation one times. So the array is like this, which is the 65747, 65747. 1 minute. So the basically the array is like this. Yes, and the number of operations you need to perform is the one. So you see here that why you sure that the which index you will choose. Let's say if you choose to this index and this index, so the appended value will be the 6 plus 5. So this is the odd, then you need to add 1 into this. So the value of for this will be the 12 by 2, which is the 6. Means you need to append this 6. Let's say if you choose to this 2 maximum element, so you need to append the value which is the 7. But if you choose, let's say if you choose to this two indexes 4 and 5, then the appended integer means the integer that you need to append will be the, so this is the odd sum, so you need to add the 1 into this, so it will be the 10 by 2 will be the 5, means you need to append the 5. Why I will choose to the minimum value that I will append, means why I will append the minimum value, because after the key operation the append value is present in the array, so that the it will also add in the sum. So if anywhere the value added in the sum is lesser, let's say appended value is x, so if x is lesser, then the whole whole value of the sum of the value of the array will be the minimum. So our task is to append the minimum possible value in each time, not the maximum or not the greater than the minimum value. So how I will get the average of the two minimum? How I will find the minimum value that I can append? It is basically, see here. If you choose two minimum element and take the average of this, means I will perform the operations on two minimum element. Then it takes the minimum value, and after that you can append. So see this test case. So the array is like this: 65747. So to find the two minimum element, I will sort to this array. So sort after to sort this element, I will got the array like this. So and the value of k here is 1. So in the first operation, I will choose two minimum element and I will add to this into the sum, uh, and I will perform operation into this, and I will append into the array. So the after the performing operation on this, let's say ith element is this and the jth element is this. So the value is the 4 plus 5, which is the odd. So 4 plus 1, 5 plus 1 by 2, which is the 5. So basically, you need to append the 5 into this array. After it, the value of our the array, means value of all the number of operations required. So I append the 5 into the array. So after it, value of k is decreased by the 1. So k is the 0. Then after it, we not need to perform some more operations. So the our total sum of the final array will be the total value of this array, this elements. So the total value will be the 4 plus 5 plus 6 plus 7 plus 7 plus 5. So the total value will be the 15 plus 5 will be the 20 plus 14, which is the 34. So minimum I will got the 34. Minimum I got the 34. But see here if you perform the key operation, so it will not accept. Why? If you perform the key operation from 1 to k, so it will not accept because due to constraint it is a very high constraint. So if you perform the one by one operation, means k times operation, it will not work. It will give really. So how you how to think in the optimal way. So let's say I pick the same array for analyzing the problem. How to optimize this approach. So let's say value of k is the 6. That's the value of k is 6. So let's say if the value of k is the 6, means you need to perform the key operation, 6 operation on this array. So what we will do? So let's say basically uh, in the first operation you choose to this two element and append the 5 in the end. So after it, I will you show that the if you choose two number, let's say if you choose any two number, let's say x and y, the value of the x plus y plus 1 by 2 or x plus y by 2 is greater than or equal to the x and lesser than or equal to the y. It is sure. So for the next time, for next operation, I will not take to the other element. Means let's say if the value of this is a, so for the next operation, I will take to the only this two element. Why I will take to the only this two element? I will not take to the y, because in each operation I will take the two minimum elements, means first minimum and second minimum. So y will be the greater or equal. So I will neglect to this and I will take to the x and this x and y for the next operation. So I will use this approach. So let's see how I can improve, how I can apply to this. So in each operation I will uh, I will take the two minimum element and perform the operation. So in this first operation, I will take the minimum element, means two minimum, and perform this operation. After it, the value of k is become the 5, multiplied by the 1. This is not included in the array. So I see here. After the first operation, I will choose to this two element. But see here, if anywhere the value that's it. After it, I will again choose to this two element, and again I will get the 5. So what I think from the here, if anywhere the let's say if I will choose to two element, and the on performing this operation, I will get the value a that is equal to the x or y, then uh, x and y. So for the next time, uh, again on performing this operation, it will always give the same result a. Means what I want to say, if anyone, let's say I will find the 5 and 4, I will in the any operation I choose to two element 4 and 5. Then after the performing this operation, means 4 plus 5 plus 1 by 2, because it is the odd, then I will add one more in this operation. So it will basically the 5. So I will check is the 5 is equal to this element, means first minimum or second minimum. So if it is equal, then after it, I will take, I will, uh, means after it, in other operation after it, it will always give the same result. You can verify from the here. Let's say 4 and 5. So after it, again I will take to this two element. So it will same as the previous elements. So it will also give the 4 plus 5. Then again it will give the 5. What about the sum is the even? Let's say we have the 4, and let's say it is also will fall. You treat it two element 4 and 4, and after taking the operation value is the 4 plus 4 by 2, which is the 4, which is again equal to this or equal to this. So on taking this operation, on performing this operation, I will get the 4. After it, again I will take to this two element, and again I will got the operation 4, means operation answer is the 4. So what I see from the here, let's say we have the 6, 7, 8, 9. So I will take two minimum element in each operation, and if anywhere the value of the operation, value of the current operation is equal to the either second max minimum or either first minimum, then I will stop from the here, and after it, for each operation after it, let's say here, let's say if after the any operation I got the value 5, which is equal to the first minimum or second minimum. So after it, after this operation, we need to perform the two more operation. Then after it, it will be the 2 into 5, means for each operation it will give the value 5. So the for two operation it will be the 2 into 5. It is pretty simple. So initially what I will do, initially I will sort the array, and after the sorting I will pick each in each time I will pick the two elements, means two minimum element. So initially I will add to this minimum element in the sum, because after it, in the final we need to add this array. So initially I will add to this into the sum, and what I will do, I will pick to the first minimum and second minimum, and I will move till the value of k is greater than the 0, and the value of the current operation is neither or equal to the first minimum or second minimum. Then I will add to that value of the a rather than the appending to this a. So I will add to this a into the sum, and after it I will check to the and I will update to the first minimum and the second minimum, and I will decrease to the value of k by the 1, and after it, let's say if anywhere I got the same value, uh, means while answer of the any operation which is equal to the first minimum or second minimum, then I will break to break at that point, and if anywhere the k is greater than the 0, then I will add to the k into the value of a into the answer. So move on the code. So first I will take the t, which is the test case, and for each test case I will call for the solve function. And in the solve function, first I will take the two integer n and k. First line I will take two integer n and k, which is the size of the array, and k, which is the number of operation you need to perform on the array A. And after it, I will take the array input as an input, and I will initialize our the answer by the 0. There is no need to initialize by the 0. You can initialize by any number. No, sorry. I will slide the answer. Here the answer is the initial sum. The initial sum is the 0, and after it I will sort the array, and I will take after the sorting I will take the first minimum and the second minimum. You can see here the value of n is greater than equals to 2, so it will not the give the runtime error. So after it I will add to the first minimum and second minimum in the array, and I will move on the an loop, which is which is there is no condition to break after in the while loop. Inside the this loop I will find the appended value that we need to append, and if anywhere the sum of the first minimum and second minimum is even, then I will increase to the appended value and add to the into the answer x rather than the appending to it into the array, because when I will append to this array, then array becomes the larger, then there is no need to append. And I will take the if anywhere the value that I append is equal to the first minimum or second minimum or k is 0, then I will break and I will find the last appended value and store into the x1. And if anywhere it not holds, then I will update to the first minimum and the second minimum. So if anywhere the last appended value is lesser than or equal to the first minimum, so I will uh, put the first minimum is the x and the second minimum is the a. If the value of the last appended value is greater than the first minimum, means basically this is the second will become the second minimum, which is the I will up by which I will update to the second minimum, which is equal to the x. And after the outside of this loop, and if anywhere the k is greater, then I will add to this number of operation, means how many the appended value in each time will be the k into x1, and I will add into the answer. After it, you see here that you from now you add this element into the answer, this two element into the answer, and the future appended value in the answer, but you not add to this element into the answer. So you will go from the 2 to n minus 1 and append to each element into the answer, and after it you can print to the answer easily. So this is the straightforward problem, and after it the time complexity of this problem will be the Vigo of n here. Here you can see the Vigo of n, and here I will go Vigo of L log n, means no L log n no. Let's say you have the first minimum is the 1 and the second minimum is the 10 to the power 9. So in each time it will be the give the mid element. After it, it will always again give the mid element. So let's say see here. Let's say if anywhere the 10 and 15. So in the first operation, after the first operation, you got the 25, and after it you again got the minimum mid element. Again it will be 12. Then again you got the 10. So you got the 11, means you can maximum got the log of the total number of operation will be log of the first. The, to, the time complexity for this will be the Vigo of n for to table on the array, and plus log of the uh, difference of the first minimum, second minimum minus first minimum. So the total time complexity will be the n plus the log of first minimum minus second minimum minus first minimum. So it will be the work equal was the distance, the difference of this will be the maximum 10 to the power 9. So the maximum time complexity will be the 10 to the power 5 plus log of 10 to the power 9. So it will be the work properly. So that is all for today from my side. Thank you, everyone.